um, what's happening with this thing here? So why is it that we had to have acidic conditions for this particular redox reaction? Okay. Well, as it turns out, you can't just go and combine any redox reaction and get a reaction out of it. All right, let me say that again. You can't combine any oxidation reaction with any reduction reaction and expect it to go. That's just not how chemistry works. Okay? So there's something that we call the activity series. Some of you have been asking me about this. When are we going to get to the activity series? Here it is, okay? And I'm not going to spend a whole lot of time with this. You do not have to memorize the activity series. If there are any questions about the activity series, like in an exam or something, you'll have the activity series to reference. And so what does this mean? What does the activity series mean for us? Okay. Well, look, first I want you to note all of these reactions are written as oxidations, right? We see that? They're all written as electrons, as products. So electrons are being lost, right? Oil rig, oxidation is loss. So now there's 3 points to keep in mind from this, okay? A metal cation, I'm going to box that. A metal cation on the list will oxidize any metal above it in the activity series. That's the same thing as saying a metal, not a metal cation, but a metal, will be oxidized by any cation below it. Okay, so let's do this first example. Okay, lithium solid. A metal, so we're picking on metal, will be oxidized by any cation below it. So what does this mean for a reaction? Well, this means I can't combine lithium solid and potassium solid and get a reaction. But I can combine lithium solid and K plus aqueous, and I will get a reaction. And what's the reaction going to be? Well, it's got to be lithium plus aqueous plus potassium solid metal. Okay? But I could not write this reaction the other way. In other words, if I now write, let's see here. If I write lithium plus K solid, so I'm basically writing this reaction in reverse. That is no bueno. I want to put a big X through it, okay? So that's what these two points are. They mean the same thing. It's just two different ways of saying it, okay? So a metal cation on the list will oxidize any metal above it. So look, when I said lithium plus, there's nothing above lithium plus. Lithium plus can't oxidize anything, okay? But what about saying it the other way? A metal will be oxidized by any cation below it. Well, look, this means every single one of these cations could oxidize lithium metal. Okay, so that's what that means. All right. So now, why acid? Okay, right? In this problem, we had to have acidic conditions for this thing to go. And I haven't shown you the activity series of permanganate just with iron, but essentially what the reason for having to include acid in some particular redox reactions is because now if you look at this right here, any metal, so remember the metal in this table, those are all the things on the left, all the reactants. They're not the cations, the metal. Any metal below hydrogen will not react with H+. So it's the same thing we set up here. It is. It's really the same thing. It's saying that any metal below, right, any metal below will not react with H+. Okay, it's just like saying the K solid cannot react with the lithium plus. Okay? But the reverse is true. So why is this important? Well, this is important because, for one, there's a whole bunch of other stuff that's not on this list, such as permanganate. Okay? And for that matter, is iron on this list? Oh, there's iron. And you can see iron is actually above. Okay? However, when coupled with permanganate, that's why it needed the acid, because permanganate's not on this list. So apologies for that. But another cool observation of this is, look, I'm going to point out silver, copper, and gold. My wedding ring, it's got silver in it, and copper. It's actually an alloy. It's a copper-silver alloy. I could take this thing. I wish I had a big bucket of acid right now. Not the stuff you take at Burning Man. I could drop this into a giant vat of strong acid. Nothing will happen to it. If I had a giant vat of strong acid right here, I would do it. I would drop my wedding ring right in there because I trust the chemistry. It will not react with it, and that's why we make jewelry with silver and gold, right? You'd be really bummed out if you spent several $100s on a gold ring and then it got oxidized by some acid. Not cool. Well, what about the copper? Well, we make pipes to deliver water out of copper. And that water can get acidified, okay? And if those copper pipes were corroded by acid, that'd be a really bad thing for all of our public utilities. So that's why we make these pipes out of copper. That's one of the reasons why we make these pipes out of copper. Okay. Same, you notice platinum is on the list too. Mercury is on the list. So this activity series is pretty cool. It's a pretty cool predictive way of predicting what's going to react with what. So you do not have to memorize this list, but I do want you to recognize, if you were given the activity list, recognize that I can go from metal to cation down the list, but I can't go from cation to metal. Okay? And so anything below the hydrogen on this list means it will not react with the H+. Okay? So I'm going to move